Dear students, myself Professor Govindema, Department of ECE, PSMSRKIT, Nipani. Today we will discuss some experiments on Analog Circuits Lab. This is for fourth semester Electronics and Communication Department. In part B, the experiment number 2 is narrow bandpass filter. This is first, before discussing about the narrow single stage bandpass filter, first we will discuss about the single stage bandpass filter, which consists of three resistors R1, R2, R3, C1, C2, and the op amp. Okay, the op amp, here the input is given to the inverting terminal pin number 2, and the pin number 3 is given to the ground through a resistance, and pin number 4 is connected to the minus 12 volt supply. Pin number 7 is connected to the plus 12 volt supply. Okay, this is the output. In single stage bandpass filter, C1 and R1 determine the low cutoff frequency F1 and high cutoff frequency determined by C2 and R2. The design for single stage bandpass filter is A. Selecting the value of C2. B. R2 can be determined by XC2 equal to R2 at F2. F2 is higher cutoff frequency. Then R2 is equal to 1 divided by 2 pi F2 into C2. We already taken the value of C2, and F2 also we determined. Okay, then we can substitute, then we will get the value of R2. R1 can be calculated in relation to R2 for the desired voltage gain. Here we know that the voltage gain is equal to minus R2 divided by R1, inverting gain. Here we know that we can take assume the value of gain, and we know the value of R2 here. Then we can substitute those both the values. Then we will get the R1. C1 can be calculated using XC1 is equal to R1. Here R1 is equal to 1 divided by 2 pi F1 into C1. R3 equal to R2. The bandwidth for single stage bandpass filter is F2 minus F1. Here I will discuss one parameter, that is Q factor, which is selectivity of the filter in passing the center frequency and rejecting the other frequencies. Here Q is equal to F0 divided by bandwidth. Here F0 is center frequency. We will get this center frequency using the equation F0 is equal to square root of F2 into F1. Now we will discuss about the narrow single stage bandpass filter. Only the changes for the single stage bandpass filter and the narrow single stage bandpass filter, just we can connect this R4 resistor, 130 ohm resistor. That is only the difference. Why we connect that resistance R4? Reconstructing the single stage bandpass filter, it is seen that if F1 and F2 are brought closer together to narrow the bandwidth, C2 will affect the low cutoff frequency F1 and C1 will interfere the F2. To encounter this, R4 is included as the circuit input. This modification produces larger Q factors and narrower bandwidths. Just to discuss some equations here. C1 is equal to C2, R1 is equal to 0.5 R2 is equal to 2Q into XC at F0. Q square is equal to R1 plus R2 divided by 2R4. Here how we can design the narrow bandpass filter. First we can select the C value. Using that C value we can determine the R2 value. B, other components are determined from the appropriate equations. Previously we discussed some equations, and these equations now we go for the procedure. Here we are constructing the narrow band pass filter using the PSpice arcade capture tool. Yeah, just we go through some procedures here. Just follow my cursor here. Arcade family release 9.2. Double click on capture CIS. Go for file, new, project. I'll give the name narrow band pass filter, and here we can choose the location where we can save the project file. Okay, browse. Okay, here save the experiment program files arcade capture in samples. Okay, then go for OK. Okay. Yeah, click on plus here, plus sign. Click on schematic 1. Click on page 1. Just remove this, erase it. Here we can pick and drop the components. What are the components required here? Resistance is required, capacitor is required, LM741 op-amp, and VDC, DC voltage, and AC voltage. Okay, to pick and drop the components, we can use the keyword P. Okay, here to select the resistance here, but we can select the op-amp. Select the library op-amp here. In part here, just search it LM741. Okay, and place it here. Escape. Next, P. Select unlog library. R. R stands for resistance. Okay, as per the circuit, we can place the components. Now go for P, click on P and select capacitor just here. The library is analog. Just type here in part place. Okay, as per your circuit, you can place it here. Here one capacitor, it is C1, and one more is at this place here. Okay, after this, select the voltage supply. Here for that, select the library source. Click here, right here, VAC. Okay, and place it here. Then pin number 4 and 7. You give the voltages. Again P. Type here in part VDC, DC voltage. Okay, and here the pin number 7 positive voltage, that's why I rotate it here. Pin number 7 positive polarity, and here the pin number 4 is connected to minus 12 volt, that means rotate here, the pin 4 is connected to negative terminal. Okay, all the components pick and dropped here, and next we do the connection. To do the connections, just press the key W. W stands for wire. W, just only one click. Move to the next terminal, just only one click. Then again connect this one, again connect this R2 to input supply. Take here. Then just follow the cursor. If you take the ground here, it's here, the ground terminal here. Click on that, select 0 design cache, and place it here. The input supply, PAC, DC, now one more connection will be left here. All connection is completed. Now you can assign the value as per our design. R1 is just click on that resistance value. Already it is there. Double click. $120K. Okay. Next R2 is 60K. Then R4 is 130. R3 is again it's 120K. Okay. Then capacitor 0.04 micro. That means just type small u. Then the supply voltage is 12 volt. Just type 12. No need to write minus 12 because already negative terminal is connected to pin number 4. It becomes minus 12 only. I hope all the values are given here. This is the complete circuit we already built. Now, what is the next procedure? The next procedure is go to new simulation. Here, give the simulation name. I will give bandpass filter simulation sim. Create. Here we can do some do the simulation. We can edit the some simulation settings. Analysis is there. Analysis type you can take it here. AC sweep and logarithmic decade. Starting frequency I will take 300. 300 is F1. F1 means lower cutoff frequency. Then upper cutoff frequency, that means it's 3K. Select 100 at the points or decade. Here this 300 is F1, lower cutoff frequency. Okay, 3K is upper cutoff frequency. Okay, in between 300 and 3K, the signal will pass. Actually, the bandpass filter is cascade of low pass filter and high pass filter. Okay, next here, apply, then OK. Here we can mark where we can observe the output. Here you can take the marker, voltage level marker, and place it here at the pin number 6. We can check the output. Okay, then escape it here. Then go for PSpice, run it. This is the output for narrow bandpass filter. See here, just verify the signal starts to pass from 300 Hz to 3 kHz. F0 is 1 kHz. Take the F0 value, F1 value, F2 value, and assume some values and note down the verify all the input values, either C1, capacitor, and all. Thank you very much.